Alright, so today Mr. Kleinschmidt and I were going to be talking about how to write ionic formulas using the ions. So let's go ahead and let's take a look at some of the things that you need to know. Alright, when cations and anions combine together, they form something that's called an ionic bond. And when you have these ionic bonds, they form an ionic compound. And what you need to know about ionic compounds is that they are electrically neutral. It means they have an overall charge of 0. Alright, so we're going to take a look at some rules that are going to be used for writing these ionic compounds. The first thing you need to do is list the cation first and the anion second. Well, what that really means is look for the metal, put the metal first, and the non-metal is going to be second. Cations are always going to be metals, except for ammonium. We'll talk about that later. And the anions are always going to be non-metals. All right, so go ahead and hit pause and write down these rules for writing ionic formulas. Alright, the first thing you want to do is you want to identify what your cations and anions are and their charges. You could either look on the periodic table and look at the trends that we talked about previously, or you can look on your ion sheet. That's what I would do. I would look at the ion sheet and try to find the cation and the anion. You're going to, number 2, place the cation before the anion. Then this might seem a little bit tricky, but once you see a couple of examples, this will be very easy to you. You're going to take the numerical charge of whatever the cation is, and you're going to move it to the bottom right of the non-metal anion. And you're going to do the same thing with the anion. You're going to take its number, not the charge, just its number, and you're going to move it to the right of the metal cation. Okay? And if you have a 1, we're just going to say that we're going to skip it for now because it's understood that it's going to be a 1. Alright, so let's take a look at an example here. And Mr. Kleinschmidt will go ahead and write this example out for you.
Okay, so here we have the aluminum ion and the oxide ion. Aluminum has a 3+ charge and oxygen has the 2- charge. Okay, so what we're going to do is we've already got the symbol and the charge written out. And the first thing I always tell my class is to get rid of the pluses and minuses. That makes it kind of easier for them to understand what's going on. Okay, so if we were to rewrite this without the pluses and the minuses, it would look like this. Okay, and then step 3, as Mr. Herzog was talking about before, is to take the numerical value for the cation, which is the 3 right here, and you're going to move it to the bottom right of the anion. Okay, so it's going to look like this. All right, and we still have that 2 up there for oxygen. And then the 4th step was to take the numerical value for the anion, which is the 2, and you're going to move it to the bottom right of the cation, which is right there. So we end up with this. And finally, the last thing that you're going to do is you're going to put it all together. So your formula for the aluminum ion and the oxide ion is Al2O3. All right, let's take a look at another example. All right, so here we have the tin 4+ ion and the nitride ion. Okay, so the same thing applies. So I'm going to take away the pluses and the minus. All right, so I have the 4 with tin and the 3 with nitride. And then we're going to do what I call the cross-charge method, which we did before. So the 4 is going to come down and over here to the nitrogen. The 3 is going to come down and over here to tin. So we have SN3 and N4. All right, and finally the last thing we do is we put it together. So we have SN3 and 4. All right, so our next example is with the potassium ion and then the nitride ion. So once again, we're going to remove the pluses and the minuses. So we have 1 and 3. We're going to do that crisscross or cross-charge method, as your book calls it. So we have the K over here with a 3 and the N over here with a 1. All right, and then we're going to put it together. So we have K3 and 1. Now, chemistry is a little bit different than math. All right, and so whenever we have a 1, that 1 is basically understood. Okay, so what we're actually going to want to do is just erase that 1. So our final formula is K3N. Okay, so another example of using an ion with a 1+ or 1- charge. Okay, so we'll take our magnesium, get rid of the pluses and the minuses, and our bromide. All right, so we'll cross those. So we have Mg1 and Br2. All right, and once again, remember we're going to get rid of that 1. I got rid of some of the Mg there. All right, so then we have Mg Br2. So as you can see, it's a very simple process. There's not many steps involved. The hardest part for you guys is going to be figuring out the charge and the symbol for each of the ions. Okay, so every ion that we've dealt with so far is what we call a monatomic ion. Okay, and the prefix mon means
Uno.
1. Okay, and then the stem atomic means atom. So we've dealt with ions that are only one atom. Okay, things like the N3 minus and the K1 plus. I wrote the wrong thing there. All right, so N3 minus and K1 plus. You can see that there's only one capital letter, so these are what we call monatomic ions. Okay, so now we're going to talk about what are called polyatomic ions. All right, and as you can see here, zinc has only one capital letter and is therefore a monatomic ion. All right, but as we come over here and look at our anion, you see that we have a capital letter here and a capital letter here. And that's what we call a polyatomic ion. Okay? I'm going to change the color a little bit. So our steps are still the same. So we'll keep the Zn2 and the NO3 and the 1. Okay, but this NO3 right here, we're actually going to change to a different color. We're going to go red. Okay? And anything that is in the polyatomic ion, so that whole entire formula, this thing right here, you cannot ever change. You cannot touch it. The only thing that you can touch are the numbers here and here. All right, so the same rules apply. So the 2 comes down over here, the 1 comes down over here. All right, so we have then Zn1 and NO3. Now this is where it gets a little bit difficult, okay, because some students like to put a 32 right there, okay, and that's not going to work because we don't have 32 oxygens in this compound. We have 2 NO3s. So the easy way to change that is to just put parentheses around the ion. All right, so we put parentheses around the polyatomic ion and then put the 2 from zinc on the outside. Okay, and I want to show you why we do that. All right, so what we have here is zinc, and it has a 2+ charge. And what we have here is NO3, which has a 1- charge. Okay, and we need to get those to be equal to each other. So in order to get them equal to each other, we need another NO3 ion to equal out the 2+ charge of the zinc. Okay, so what we have is 1 zinc and 2 NO3s, and that's why we're going to put that in parentheses. Okay, so here's another polyatomic ion, all right, and the same rules are going to apply. All right, so we get rid of the pluses and the minuses, okay, and now we'll do the same thing, so we'll crisscross the charges. So here, our NH4, which we call the ammonium ion, it already has a subscript, a number. Okay, and whenever you see one of our polyatomic ions, it's always going to have, it's usually going to have a subscript. Okay, but you need to make sure that you put that in parentheses. So we have the 2 outside the parentheses, and then the S. Okay?
Yeah, basically, when you cross your charges, and if the subscript you're moving is anything higher than a 1, you're going to be putting that polyatomic in parentheses. Okay, so here's another semi-difficult one if you haven't seen before. Notice here that OH hydroxide ion has 2 capital letters, but it doesn't have any of those subscripts. Okay, so a lot of students get confused here and they don't end up putting the hydroxide in parentheses. And you still need to because it's a polyatomic ion. All right, so once again, we'll take away the pluses and the minuses. All right, and we'll do crisscross. So we have SR, the 1, and then that OH, is, like we said before, needs to be in parentheses. Okay, and the 2 is going to stay outside of that. All right, so our final product or our formula is SR
OH2.
Mr. Kleinschmidt, can you show them what not to do? What most students will do with this problem?
Okay, so what most students do with this problem is they get to this point where they have the 2 and the 1, and they won't put the OH in parentheses. So they'll do SR1 and they'll do OH2. Okay, and when they put it together, they get SrOH2.
And that's a no-no. You're not supposed to do that.
And that's a big no-no. Okay, because what that is actually telling us is that we have 2 hydrogens and only 1 oxygen, when in actuality we have 2 oxygens and 2 hydrogens if we distribute the 2 to whatever's inside the parentheses. Okay, so make sure that you're very careful when using hydroxide.
All right, so here's another kind of a tricky polyatomic ion. It's acetate, this thing right here. And the thing you need to know about it is you just keep that together. Keep that C2H3O2 together and don't split it up whatsoever. So what we're going to do is you're going to take your 2, all right, you're going to bring it to the side over here, take the 1, bring it over here, and it's crossing the charges. I'm just kind of showing you another way to do it like what Mr. Kleinschmidt was doing. So you're going to take your SR, and since this charge right here is a 1, you simply ignore it. If it's just one element or one ion by itself, it's understood that it's 1, and then you just write the other thing right here, the anion, so C2H3O2. And now what a lot of people do is they'll just put a 2 after this. And you got to think about it. Well, when we start counting our ions, when we start counting our atoms, which is coming later, you're going to say, well, do I want 22 oxygens? No. So to help us with that, you enclose this in parentheses right here, and that's what your answer should be. All right, SR, then in parentheses you have the acetate ion, C2H3O2, and then you have a 2 on the outside of the parentheses. Okay. One thing that you need to know is about reducing, because remember, this is, when we talk about ions, you want them to be in the simplest form. You want the simplest ratio of the atom. So if you can reduce, we're going to show you how to do that, and you can't do that. But just remember, you can't reduce any part of the polyatomic ion. Okay. So here's an example right here. What do we mean by reducing? Well, if you think about Mr. Kleinschmidt said, you want your charge, total charge has to add up to 0. So if you have magnesium right here with a +2 charge and oxygen with a -2 charge, when you add those charges up, they already are 0, and you don't have to add anything else. So when that happens, you just write the symbols together, Mg and O. All right, and then we have the same thing right here. All right, when you add this up, +3 and a -3, that adds up to 0. So if you have equal but opposite charges, just go ahead and just put the cations and the anions together, and that's your answer. Okay, and let's talk about this one. Now this one's a little bit different. So let's take this one. So you cross the charges, so we'll do it like Mr. Kleinschmidt said. He had a PB, you get rid of the charge, so you just have a 4 and an S with a 2. Go ahead and bring the 4 down here, and the 2 goes right there. It becomes PB, 2, S, 4. Now this is where we start talking about reducing. All right, if something like this happens, if both of these subscripts right here that are not part of the ion itself, if you put them both here, you can reduce these. So what I would do is say, I can divide that by 2, I can divide that by 2, and what happens here is this becomes PB, S2. Okay, just remember, you want the simplest ratio of the atoms, and this is the simplest ratio to get them to equal 0. Okay, now let's take a look at this one. This one's kind of tricky as well, but not too bad. Remember, we do the same thing. So if you just have a plus, that actually means a +1 or a 1+. It doesn't really matter which one you choose. All right, so if you just see a plus sign or just a minus sign, that just equals 1. All right, we do the same thing. So the 2 is going to come down here. All right, so you have Li2SO4. Now, a lot of people think, well, I have a 2 here and I have a 4 right there. Am I supposed to reduce? The answer is actually no, because this 4 is part of this polyatomic ion. You can't get rid of that part of that polyatomic ion. So it has to stay there. So my answer would be Li2SO4. All right, so we're going to talk about some tricky ions, and one of them that I find that students really struggle with is the Mercury 1 ion. Now there's 2 of them. There's Mercury 1 and there's Mercury 2. This is Mercury 2. So if you think about it, it's just a Mercury that lost 2 electrons and now has a +2 charge. This is going to be Mercury 2. let's take a look at Mercury 1. Well, what does that 2 mean? That means that there's 2 of them, and they both overall have a +2 charge. So let's take a look at that. So really, Mercury 1 is actually 2 mercury atoms, each having a +1 charge and an overall charge of +2. That's what it means by the mercury ion. So let's take a look at this right here and do the same thing. So this 2 is going to come right here, and this 3 is going to come over here. Treat mercury 2 like a polyatomic ion. So you have Hg2, N2, and then we have to put a 3 right here. But this has to be in parentheses, okay? Because we don't want 23 mercuries. We want 3 mercury 1 ions, okay? So make sure you pay attention to that because you might miss it. All right, we've got another one with mercury. This is with mercury ion with the oxide ion. All right, do the same thing, but look, they're equal opposite charges. Remember what they do, they just kind of cancel out. So it's just going to be Hg2O. Now, just so you know, this little 2, it has to stay with that Hg. All right, here's another one. This is with another polyatomic ion. This is the phosphate ion right here. So you're going to take this 2, bring it over here, take this 3, bring it over here. That's called crossing the charges. So you have Hg2, that's going to be in parentheses, and you're going to have your 3, and then we have a PO4, and you have a 2 on the outside. But look how funny this looks. We don't want 42 phosphates, we want 2 of them. So you have to put this in parentheses as well. And that is okay. If you have 2 things with parentheses, that's fine. All right, here's another tricky one with the peroxide ion. Just like mercury 1, this 2 has to stay with that oxygen. All right, so let's go ahead and take a look at a couple of examples that include peroxide. Here's one right here. All right, so we do the same thing. You cross your charges. That 2 is going to come right here, and the 1 would go right here, but you simply just ignore it. So you have Na2O2. Now, a lot of people think, well, do I need to reduce this right here? Well, think about this. If you reduce it and it changes this right here, that's no longer going to be peroxide. So you cannot reduce it. So this is my answer. I would just leave it Na2O2. All right, here's another one. We have Ba, or it's barium with a +2 charge and peroxide with a -2 charge. And we do the same thing. So the 2, we cross the charges, but take a look. They're equal but opposite, so we can cancel them out, and you just write the symbol. So BaO2. All right, what I want you to do is go ahead and try these examples in your textbook on page 273. Try number 10. There's an A through D. There's only 4 problems. Go ahead and try that and bring it back to class tomorrow.